Have you ever tried to tell someone exactly where something is? Not just, over there by the tree, but with perfect can't get it wrong precision? Well, today, we're diving into a beautifully simple system that was designed to do just that. We're talking about coordinate geometry.
But seriously, let's think about that for a second. How do you do it? I mean, if you're trying to guide a rover on another planet, or even just tell a delivery drone where to land, a little to the left just isn't going to cut it. Any kind of ambiguity, any guesswork is the enemy. You need a universal language for location.
So, we're basically trading in those vague, hand-wavy descriptions for the crystal clear world of math, a world where any location, any single point in space, can be nailed down with just two numbers inside a couple of parentheses. It's a huge leap from guesswork to a total guarantee.
So, how do we pull this off? What's the secret? Well, we use one of the most powerful and, honestly, elegant tools in all of mathematics, the coordinate plane. You can think of it as the ultimate map, the thing that makes this whole system of precision even possible.
And this right here is really the big idea from our source material. The coordinate plane isn't just a bunch of grid lines on a page. No. It's a powerful tool that literally translates the physical world into the language of numbers. It's all about using a few simple rules to create perfect order and find a clear path to any spot you want.
The address for any point has a special name. It's called an ordered pair. The first number is your x-coordinate and the second is your y. Now that word ordered is absolutely key. Why? Because 3-5 is a completely different location than 5-3. It's just like how 123 Main Street is totally different from 3 Main Street, apartment 12. The order matters. Okay, so we've got our address system down. Now let's explore the city grid itself. What are the basic rules of the road for the coordinate plane? Everything, and I mean everything, starts with two number lines that cross each other. First, you've got the x-axis, which runs side to side, horizontally, like the horizon. Then you have the y-axis, which runs vertically, straight up to the sky and straight down. These two lines are the absolute backbone of our entire map. And that one special spot, right where they intersect, that is the most important landmark of all. We call it the origin. Its address is 0, 0. And here's the rule. Every single time we want to find a location, our journey always begins right here, at the center of the universe. Now check this out. These two axes slice the entire plane into 4 distinct regions, and we call them quadrants. And this sets up a brilliant, super simple pattern. Quadrant 1 in the top right is where both x and y are positive. Quadrant 2, top left, has a negative x and a positive y, and so on around the grid. The signs of the numbers are like instant clues telling you which neighborhood a point lives in. All right, that's enough theory. Let's see how this actually works. It's time to put these rules into action and actually start plotting some points on our map. Okay, let's find the point 4, 5. The process is always the same. It's like a recipe. Step 1, you always start at the origin, 0, 0. Step 2, you look at your x-coordinate, which is a positive 4, so we run 4 units to the right. Step 3, from there, we look at the y-coordinate, a positive 5, so we climb 5 units straight up. And boom! There it is, right in quadrant 1, exactly where the two positive signs told us it would be. See, the system just works. It's perfect. But what happens when we get negative numbers? Let's try plotting -3, 2. Don't worry, the same exact rules apply. We start at the origin. Now, the x-coordinate is -3. A negative x just means we move left instead of right, so 3 units to the left. The y-coordinate is a positive 2, so from there, we just move 2 units up. Simple as that. And that lands us squarely in quadrant 2, a negative x, a positive y. You see? The signs basically gave us a little cheat sheet. They told us exactly where that point was going to end up before we even started counting the steps. It's just beautifully consistent. Okay, your turn. Let's do a quick challenge. This one's straight from our source materials homework section. What about the point 0, 7? Think really carefully about that 0. Where does that point live on our map? If you said it's not actually in a quadrant, you nailed it. An x value of 0 means we don't move left or right at all. We just stay put on that main vertical line, the y-axis, and go 7 units straight up from the origin. So remember, any point with a 0 in it is going to live directly on one of the axes. So, as we've seen, plotting points is a really simple, methodical process. But let's zoom out for a second and think about the bigger picture here. This whole system isn't just about finding dots on a grid. Now, this is interesting. The source material we've been using for this explainer actually ends with this quote from the book of Proverbs. It says, "Wisdom is the principal thing, therefore get wisdom, and in all you're getting, get understanding."
So why include that? Well, the source is drawing this really powerful metaphor. The idea is that the same careful, step-by-step method we use to find a precise point on the plane can be a model for how we seek clarity and understanding in all areas of life. It's about taking a journey from confusion to clarity.
And I think that's the big takeaway. What coordinate geometry really teaches us is that a few simple, elegant rules can bring perfect order to what seems like an infinite, chaotic space. And that leaves us with a really fascinating question to think about. What other simple rules, what other elegant systems like this help us make sense of our complex world?